Okay, thank you for being part of this tutorial. We're going to start out with designing the PCB. We're going to use Easy EDA for this. I've never used any other software, quite frankly. This has been able to satisfy my needs for this project. This may be good for you, maybe not. I'm not sure, but I do like what they offer, and it's no charge. We're going to first start out by clicking the folder icon here, going to New, and then adding a PCB. Once you do that, let's set some parameters. Set the units to millimeters. The grid size to 2.54, and eventually I'm going to do the routing width to 0.9 millimeters. I haven't done it so far. It is in here at the front, but I do recommend that you go ahead and do that. Be sure to set the board outline first. Because this is a 100 by 70 millimeter project, I'm going to start at 0, 0, and of course extend the lines to match the board width that I have ordered for this tutorial. What I found here through a little trial and error as I go through is that the corners aren't exactly squared. So if you zoom in on each corner, you can go in and kind of clean up the corners. So zoom in quite deeply and you can see the different points. If you want to get rid of any redundant points, what you can do is this allows you to really get granular with the corners, as well as you can see this one's not squared. So double clicking that furthest point will actually just take it out of the lines. Found that's a real helpful, easy shortcut for you. Yeah. Now we squared the border layer. We're going to go back the top layer here, and the next is to select the copper area. This is a bit easier of a tool, but basically I'm going to put it right on top of the board outline. For this project, once again, that's what works. That's what works with what I'm doing here. All right, let's cue up some background music and just get started. Okay, well, we finished the design. Now it's time to prepare for the PCB. Got a pair of gloves here. What you don't want to do is get the oil from your fingertips or from your hands getting on this board. It could mess up with the toner transfer. You can see the supplies for the transfer that I'm using off of the Instructables website. So what we have here is a little bit of steel wool. This is the finest grain I could find for the steel wool. Super fine is what you're looking for. A little bit of acetone. I find that putting in a spray bottle helps cut back on waste and also control a little bit of the spray as well. So what you want to do is get all of the oxidation off of the copper that develops with time. I find that you also need to pay attention to the corners. You can get the edges pretty well, but you somewhat miss the corners if you don't really specifically set them to the side and make sure that you get them with the once you cleaned off both the boards very well with the acetone, give them a wipe down with some rubbing alcohol. This is Alright, now it's time to do the actual transfer. I'm going to use this this particular paper. I ordered it off Amazon. You can also get it off of eBay. Once again, look at the Instructables for the notes of where to order this from. To make it stretch out just a little bit further, I'm using cardstock to back the toner transfer paper. We need something quite rigid, so you'll understand later. Tape, partial tape at the bottom. Okay, so we're going to print, we're going to do an export, or in this case you can just do a print. We'll select PDF. Don't mirror it. It's not going to be necessary for this project right here. Some other tutorials will show that you need to mirror, but we're not doing it for ours. Also want to print black and white. When you export this, this is going to actually create a PDF file. I actually have a full version of Acrobat here, so I get the luxury of kind of modifying what I did. I take this particular image and I'm going to put it onto a regular size blank piece of paper, or letter size PDF, so I can actually just kind of cut and paste this from one to the other. Once again, I'm doing this because I'm printing out 2 copies at a time. This is just for a little bit more insurance, but like I said, it's just not required. But because of the process that I'm going through, I find that having 2 available for when you get it right is just nice to have that backup, and it doesn't cost you any extra in material because we've already split the toner transfer paper in 2. Very important here, when you're printing out, be sure don't scale the image. If you scale it, you could actually mess it up and the pins will not line up. You can see that we didn't scale and the pins are lining up, so we're in good position here for this particular one. Once again, remember, we're etching copper, so it's actually going to be backwards. So this is what the board will actually fit on. So make sure that the diagram matches what the board needs. Next, we want to make sure that this is actually going to print out on the toner paper. If you don't have these images lined up properly, you're going to miss the toner paper entirely, which kind of defeats the purpose. Why cardstock, do you ask? Well, that's because we're going to print this 3 times. 3 times on the same sheet of paper. I want a lot of toner for the transfer. And what I found is that once is not enough, 2's okay, but when you get it lined up right, 3's better. I almost started slicing the wrong edge on here, and what I realized is that you really want to line up the shortest edge to what you're going to line up with the board later. Be careful not to fold or crease the toner transfer paper, because you'll actually remove the toner from it, rendering it useless for this project. There's no need to trim the excess off. Just trim the part of the board that you're going to line up with on the PCB, and everything else you can just leave. So there's no need to take all of the excess off. I will take the tape part of the toner transfer paper off with this slice right here. Use the edge of the laminate holding paper to line up your PCB. Usually when you're pulling these PCB boards, there's a straight edge and there's a cut edge. You can see where I line up the toner transfer paper with the straight edge, using the laminate holder to line everything up. Once you get it lined up, be sure to hold down and pinch the board pretty good. You don't want this paper slipping off of the PCB as you're inserting it into the laminator. We have the first pass done, and then I'm going to take it out and do a quarter a turn, and we're going to do this a total of 4 times. So let's speed it up. Okay, we finished up with the laminator. Now it's time to let the card cool off a little bit. Don't do this while it's hot. So before you peel off the toner transfer paper, let the board cool down a little bit. When you do the transfer, not all the toner will go from the toner transfer paper to the PCB. So I use black fingernail polish along with the Sharpie to help touch up any of the areas that need a little bit more TLC prior to doing etching. Okay, so we're using acid here. Please use a well-ventilated place. I'm using my microwave vent because it takes all the fumes outside the house. Alright, the mix is pretty simple. I'm using 2 ounces of hydrogen peroxide and 2 ounces of muriatic acid. This creates a good combination for the etchant. Be sure to use the hydrogen peroxide first. Careful when opening the muriatic acid. Fumes come out. They stay coming out the whole time out of this. So I already have the vent running, and as I'm pouring this, I'm just kind of careful not to inhale the fumes. So after about 15 minutes, you can see that all the copper has etched off of this. This depends on the temperature of the etchant, how much agitation you do, where you get the board, so the time might vary. But be sure to inspect it under the light. Make sure that all the copper is gone before removing it. Now that the copper is cleaned off of the board, it's time to rinse. You can see I'm using a sink that is already full of water along with running water in order to dilute the acid as I clean off the board. Acetone and steel wool will help remove the excess residue, being the toner in this case, off after the rinse is complete. Alright, we're in for the home stretch here. It's time for drilling and soldering. Hindsight, I should have used smaller drill bits, but this is all I had in the kit at home.